Lesson 7 and Lesson 8. So, future value of an annuity. So, recap. What is an annuity? An annuity is a series of equal payments/withdrawals made at equal intervals of time. So, a future annuity is money being put in or to save up. Okay, so the formula of a future value of an ordinary annuity is FV is equal to R, 1 plus interest rate to the exponent of n minus 1 over I. So where R stands for regular payments, I stands for interest rate, and N stands for number of corresponding periods, which is always given in years. So an example is how much money must be invested at the end of each year for 4 years to achieve an amount of $10,000 if interest is at the rate of 6.25% per year compounded annually. So first, we need to start off by writing down our givens. So we're given that n is equal to 4 since it says 4 years. Our future value is $10,000 since it says to achieve an amount of $10,000. Our I is 0.0625, and we're looking for our R value, which is our regular payments. And since our equation up here is FV, we need to rearrange this to make it R is equal to the rest of the equation. So the equation is now going to be turned into this. And it's going to be R is equal to FV over 1 plus I to the exponent of n minus 1 over I. And we have to plug in the given information from here into this equation, and we will end up with this. So what I like to do with an equation like this is solve the bottom, and that is 4.39.869. And I just do 10,000 divided by 4.390869, and your final answer should be 2,277.45. And to achieve a 4 plus, a therefore statement must be given, and the therefore statement is, therefore $2,277.45 must be invested at the end of each year for 4 years to achieve an amount of $10,000. So that was future value. Now we're going to do present value of an annuity and a recap. So a present value of an annuity is the amount of money that must be invested today at a given rate and period in order to make regular payments. So the formula for present value is a bit different since there's a negative exponent this time, and the minus 1 is at the front. Everything else is the same except PV stands for present value, R is still regular payments, I is interest rate, and N is still number of corresponding periods. So an example of present value is how much money should be in an account today so that withdrawals in the amount of $15,000 can be made at the end of each year for 20 years. If the interest rate of an account is earned at a rate of 7.5 per year compounded annually. So like the last question we did, the given must be stated. So we know that R is 15,000 since it says withdrawals in the amount of 15,000 can be made. And we know that I is 0.075 since it says the interest rate of 7.5. We know that N is equal to 20 since it says at the end of each year for 20 years. So since we're looking for PV, we get to keep this equation the same, so no rearranging. So our equation is still going to be like this. And now all we have to do is plug in our givens, and your equation should look like this. PV is equal to 15,000, 1 minus 1 plus 0 plus 0.075 to the exponent of negative 20 over 0.075. And your final answer should be $152,917.35. And to achieve a 4 plus, again, for communication, you should have a therefore statement. So therefore, $152,917.37 must be in the account today so that withdrawals of $15,000 can be made at the end of each year for 20 years. Thank you for listening, and I hope you guys understand.